Previously, we've looked at binary searching. Now we are going to look at recursive binary searching. So in our code right here that we did previously, we wrote a while loop and had if statements inside of it. There is another way to do this that is similar in size, runtime wise, and it's with using a recursive method. This was learned back in chapter 12, and it is gonna take the same parameters as this binary search, so we can comment this out and write new code for it below. Now we have a blank slate. We're still going to be doing the same thing where we return an index at which the target appears in the input array, or -1. We're still going to be using the same thing. We're going to have a binary search where we return an index at which the target appears in the given input array, or -1 if it's not found. And we're still going to assume that the array is sorted. Like I said, it's still going to be the same exact header. It's going to be public static int, and we're going to call it binary search. Actually, you know what? We can leave this uncommented since we're going to compare these two. And we're going to just change the name a little bit. We're going to do R for recursion, binary search R. And we're going to take in parameters of an array list and a value that we want to find. However, we can't really write recursion with this since we only are taking in our array and value that we need to do. We still need to we need to write in these values into our recursive method. So what we're going to do is we have to make a totally separate method underneath our current method here. We're going to make a method that's actually going to do the recursion, and this is going to be public static int binary search R. Has the same names, but it's going to be different because it's going to take in different parameters. It is going to take in the same int numbers and int target, but this time it's also going to take an int min and an int max. So these are our two methods. This one's going to be writing it, and this one's going to be doing more of the calculations behind it. So inside here, we need a return statement. We're going to return binary search R, and we need to pass in our array. We're going to pass in our target value, where you are going to pass in our min value, which we will just dedicate as 0 temporarily, as we did last time up here. And then we are just also going to pass in numbers.length -1. So this is our return statement. This is all going to go into this method right here. On each pass of the recursive algorithm, which is this, the code examines the middle element. If this element is too small, the code recursively examines only the right half of the array. If the middle element is too large, the code recursively examines only the left half. This process repeats recursively, calling itself over and over again with different values as the min and the max until it either finds the target or the entire array has been examined. In a recursive method, we always need a base case. That way our loop will, or our recursion will stop and it won't continuously go on forever. If that happened, that would not be good at all. So we're going to have a dedicated base case, and that is if min is greater than max, we're just going to return -1. Basically what this is saying is, as our array, we can do this, and let's say we have our max value here, and our min value here. Well, when we do a comparison, if it's right here, if this is the value we're looking at, if we compare these, this side's going to get eliminated. Then we're going to compare these, and this is going to be our new min, and these are going to get eliminated. However, if we don't have a minimum value, but we have, let's say, a number that is in this range, it's going to eliminate this part right here, and then it's going to look at this part, and then the middle right here, and it's going to keep going until the middle value is both the minimum value, maximum value, and mid value. So that's basically what this if statement is doing. And if that happens, it can't be in the array because we've gone through all of the indexes. So it's just going to return a -1. We're going to have our else statement. So if it does exist, right, we are, or if min is not greater than max, because min is always supposed to be smaller. If min is not greater than max, we are going to go into our else case, and this is where we are going to do our recursion. We have to make an int mid again, and we're just going to copy this over to see how similar things are. We're going to have an int mid like this, and actually, to fully show how similar these are, we can copy all of this code. Recursion is basically like a loop. So if you have a code, or if you have code in a method or a main program and it's looped, it could probably be put in a recursive method. So if we paste this into our else statement, we're going to see that our mid is going to be the same. It's going to be the max that we take in, and it's going to be added to the min and divided by 2. That'll be the middle of our array. Now we have to compare. If numbers mid is equal to target, we are just going to return mid because we found our answer. This is where we start to change things. So this part is going to need a change. If the middle index is less than target, we're going to return binary search R. So it's going to go through our method again, and we are going to pass in the parameter numbers. We have to pass in our list again. We're going to pass in target. However, we are passing in a new max value, and that's just going to be mid plus 1. We also need our max value, since the mid plus 1, since if mid is less than target, that means it's going to have to be in this range right here, not in this range. So basically what we're doing is we are setting this as our minimum value. As you can see, it's going to be in the same place here as it is up here, and we are just going to keep our max value the same. We're going to do something similar here. We can actually keep this code. We can cut it, and we are just going to return binary search R, then parentheses, we're going to pass in numbers, our targets, and min value, because this is the side that we're going to be looking at, and then our max is equal to mid minus 1 as our new max value. After we do all of this, we do need a return statement still for here. Since we have an else statement in here, it's expecting a return outside of our else statement. So what we can do is we can take this if right here, because this is the only other possibility that could happen for our code to run through. So we can just cut that and make that our else statement. And we can add a comment right here of what it does so that we know what it does. And that is going to work the same as our previous binary search, except this way it's just using recursion. This is our first method that's going to call it, and this is the second method that's going to do all the math. The recursion method is just about as fast as our binary search method, basically performing the same computation, cutting the input in half in each step, and the runtime of the recursion version of our binary search that we did up here, which is now down here, is big O log n. So nothing really changes, and there's no runtime problem